Okay, so looking at this, and those of you who are watching this video, there is a Google Doc online where you can actually move your graphs around. So you can like grab this first graph and move it to either the even root graphs or the odd root graphs column, and then type on some other ones that we have in a minute. So this is about domain and range a lot. This first page is about even root graphs and odd root graphs. What's the difference between them other than we know that this is probably something like a square root and this would be a cube root? What do we know? Yep, Ben. So the domain for cube root graphs or odd root graphs are what compared to the domain for even root graphs? So this one is all real numbers and this one is not. Bless you. So in the first example, I don't know what the equation is. I probably could figure it out, but I don't know what the equation is. Is it even or odd? It's even because it starts here, and I don't know if you can tell, but it's supposed to go that way. There was a limit to what I could do. This next one is going to go this way, but this one is even, so here I go. I'm just going to move it to the even column. There is a quick sort of sketch of it. The next one, is it even or odd? Take a guess. Odd, because there's nothing here. So this is limited somehow. These numbers would somehow break whatever the equation is. So this must also be even. I'm going to put it in the even column. How about the third one? Odd, because it's everywhere. How about the fourth one? Odd. And the last one? Odd. Okay, so let's talk about domain and range for these. Going back up to the first one. What is the domain? X is greater than or equal to 0. Perfect. So x greater than or equal to 0. How about y? The range. Oh, also greater than 0, right? Yeah, so greater than or equal to 0. So when it's limited in the domain, it might be limited in the range as well. The second one, what about that? Let's say that this is, because I can't tell, let's call that 1.2. Let's just decide it's 1.2 and negative 1.2. X less than or equal to negative 1.2, x greater than or equal to 1.2. Yes. Also, just for fun, I'm going to write this in interval notation. Negative infinity to negative 1.2 and 1.2 to infinity. This is going to be something we use more often next year, although this is allowed sometimes, the inequality. The interval notation is predominantly what we use in precalculus. How about the range? Yeah, now I'm assuming that there's a dot there, so I'm going to include 0 in my range. Note that I used y for range. If you use x for range, that's silly, right? And it's something that I do. So I pointed out to you because I don't want you to do it. Okay, how about the domain for this one? All real numbers, that's easy. R. You can write as negative infinity to infinity, although that seems much more long than all real numbers. How about the range? So less than or equal to 0. You could also say negative infinity to 0, and then it stops at 0 and includes them. And I should have used hard brackets up here. Nope, soft bracket there, hard bracket there. My bad. How about the fourth one? Range? Yeah. And same for this. Same. Okay, so domain and range. X's versus Y's. I haven't used my highlighter, but are y'all comfortable with like starting here and going this way for domain and then starting here and going up for range? Does that? Okay. All right, so let's look at some actual things that we could see the equation for. Even if we don't know what sign means, we can look at these things. This is a trig function. I've told you what it is, and we're going to look at trig functions next year. We may have a chance to see a little bit of it this year. We'll see. But the range goes from -1 to 1. The domain is all real numbers. Can you see that? Like, can you imagine what this does? You might have seen like sound waves or other sorts of waves. This would just continue to go up and down like this. And I've already typed it in there so you can see. We talked about, can barely see the numbers for the second one, but this equation is something we've seen in this class. What kind of function is that? This one is written on from last year. It's not a polynomial because it has the 1/2. So what is it? No, it doesn't have an x in the exponent. What does the picture look like? No, a quadratic looks like a U. We just did this on our test. It's a what? Well, an inverse needs an original function. It's the inverse of a quadratic. What does this 1/2 mean? Radical, there you go. So I had some leftover stuff from last year. Radical function. Ignore whatever random thing was printed there. I tried to clean it up, but it didn't work apparently. So the range goes from 0 to infinity because it's talking about going here and going up. To change colors so you can see it. And then the domain started at 4 and went to the right, so x is greater than or equal to 4. So it's not a polynomial function, so it's not smooth and curvy everywhere. It stops here. Just like on page 1, this one is not smooth and curvy everywhere. I don't know if you remember this, but when I defined polynomials, I said that a polynomial was smooth and curvy everywhere. And I can tell that this is not one, and this is not one, and this is not one, just from the graph. This exercise is to help you figure out those things as well. So I've got the third one as type odd root. Can you see the odd root in the equation? Odd root. It's not an odd root. It's just an odd polynomial. And my pen is dead. So it's not a root. It's a polynomial function. The root would look different. It would be sort of squished. The domain and range is all real numbers. This has a 3 here, not a 1/3, so it's definitely a polynomial function. The next one, 1, 2, 3, so this is 4. What kind of function is this? It's another radical. It's the same equation, it's just they've been switched, right? It's got a negative x value. So instead of being the standard where it starts and then goes to the right, this one goes backwards. It's been flipped. And so the domain for this one is what? X is less than or equal to what? 4. And you can see it in the graph. You start at 4 and then you go smaller than. How about the range? 0 to infinity, y greater than or equal to 0. Here's the 0 to infinity looking one. And then the type, we call this a root. You could call it an even root if you wanted to be more specific, but a root function. This next one, it's already written out as a polynomial function, but would you know that looking at the equation? It has no exponents. They're all ones. If you multiply this together, it would be x times x times x. That would be x cubed. Does this look like Saturday night behavior? Yep. So this is smooth and curvy everywhere. The domain for polynomials is all real numbers. The range for a cubic is all real numbers. If it was an even function, like an even degree function, it wouldn't be everywhere because it would have like a minimum and then go up. So it might have a different range. So we answered that already. We could even pick out the zeros from this one. The last one, so number 6 on here, it's already written as exponential. That's kind of where we are now, right? That's what we did last week. And by last week, I mean the last week we were here. We did exponentials, we graphed them. And this looks like an exponential now because it has the x in the exponent spot. The domain for exponentials is what? The x values. The x values would be all real numbers. You can put anything you want into the exponent. Now, you and I might have trouble figuring some of those out. We might need a calculator, but they don't break the math, which is different than having 0 in the denominator or a negative square root. So the domain is all real numbers. The range is, that's supposed to say 0 to infinity, or y is greater than or equal to 0, except it's not equal to 0. It can't be 0. So we have a y equals 0 asymptote. If you remember that from before, because it's trying very hard to be 0, but there's no exponent you can give it that will actually make it be 0. This last page is mostly not filled out. So this is what I would like for you to do for me for homework. You have equations given. You should be able to look at it and go, this is this kind of graph. This is this kind of graph. This. This. Different kind of graph. And this one we don't know about. This one I labeled as rational because it's a fraction. This one's also rational, but I could write it a different way. So I would like for you to tell me domain and range for these guys. As practice for tomorrow, we'll start class by going over that. There are 3 questions on the very last page that talk about domain, disqualifiers for domain, and odd roots of negative numbers. I'm just trying to clarify some things, both from the test and domain and range, because if you get out of Algebra 2 and you don't know domain and range, then I've failed. So I would like for you to know what that is. So that's what you have for homework, 1 page and a couple questions. Go ahead, turn it on Classroom, and I'll see you tomorrow.